So in this section, we're going to talk about how we maintain normal pH in our bodies. And this is essential for cellular function, as any deviations or even small deviations can be catastrophic to cells. And it's maintained by three different systems. One, the buffering system, two, respiratory system, and three, the renal system. So the buffering system is the first of these because it is the quickest onset. Respiratory is next, and then renal is last. So let's start out with talking about the buffering system. The buffering system has three major components. One, bicarbonate and carbonic acid. This is one we're probably going to talk about and you might want to think about the most. Next, you have phosphates, that inorganic or organic phosphates that maintain the buffering, maintain pH throughout the body. And then finally, amino acids. Now, the bicarbonate and carbonic acids is one of the most important ones because it is the most widespread and plays the largest role. So you can see here, CO2 plus water yields carbonic acid, and this is through the carbonic anhydrase enzyme. Now, you guys may remember that there are some drugs that affect carbonic anhydrase, including acetazolamide. Then, carbonic acid actually quite rapidly becomes both a proton or a hydrogen atom or a hydrogen ion and bicarbonate. As we talk about acid-base disorders, you're going to notice that this system comes back into play because what we're going to talk about is that a lot of respiratory problems are caused by excess CO2, which, as you can remember whenever you talk in chemistry, that whenever you increase the concentration of one substance within these kind of reactions, it's going to shift the equation the other way, so thus making more proteins or protons or more hydrogen atoms. If you add more bicarbonate into the system, like you see in many metabolic alkalosis, that's going to shift the equation the other way and cause your body to consume more of these protons or hydrogen atoms and create more CO2, and that would be the compensatory mechanism. So let's talk about those compensatory mechanisms. With the respiratory system being first, as I mentioned, it is the second line of defense. It takes full compensation within hours versus you're going to see with the renal system, it can take days. So we maintain the pH of our body through the respiratory system by expiration of CO2. You can almost think of CO2 as an acid. If you trap more of it, it's going to cause your pH to lower. If you actually exhale extra of it, like get rid of more and more of it, it's going to cause your pH to go higher. So you're going to become more basic versus more acidic. And this is really controlled by chemoreceptors sensing changes in your pH or CO2 throughout your body. So the mechanism is that based on the pH that you have, you will find that the respiratory system will either increase or decrease the depth and rate of respirations. So if your body senses that you have a low pH, and this could be either due, but this is usually due to metabolic causes because we're going to talk about how this is a compensatory mechanism. What it will do is it will increase the rate and depth of your respiration. So it'll actually make you kind of hyperventilate. The idea being that you're going to blow off all that extra CO2. And again, CO2 kind of acts like an acid in your body. And whenever that occurs, it's going to help increase your pH and overcome. So this would be a compensatory mechanism. Now, if we decrease the rate and depth of our respirations, that's what causes, so like if your pH is high, our body's compensatory mechanism is going to be decreasing the rate and depth of respirations. So meaning that you're going to try to trap all that extra CO2 in your body so that it's going to create a more acidic area. So that would cause your pH to decrease. So remember, the more CO2 I blow out, the higher my pH goes. The more CO2 I trap, the lower my pH goes. So that's becoming more acidic if I trap, more basic if I blow out. And again, this onset of effect is rapid within minutes, and you have full compensation within hours. Now, in the renal system, how we maintain acid base through our metabolic system and renal systems is based off of bicarbonate. Now, bicarbonate's a little bit easier because you know bicarbonate is a base. So if I increase the amount of base in the system, then we're going to increase the pH because pH, higher pHs means more basic. If I decrease the amount of bicarbonate in the system, we're going to decrease the pH because there's less base in the system. You're becoming more acidic. Now, this is mostly maintained by the kidneys. So you can also excrete acid, but what we're going to focus in on is bicarbonate because bicarbonate is what we actually will test in ABG. So bicarbonate is freely filtered and it does require reabsorption to maintain acid-base balance. So we're actually going to affect this by our kidneys sensing that either you're too acidic or too basic and either grabbing onto bicarbonate or letting it go. So if we increase the amount of bicarbonate in our system, that's going to increase the pH. If we decrease the bicarbonate in our system, it's going to decrease the amount of pH. So per se, if our body does sense that our pH is high, then it's going to actually tell our kidneys that we have too much basic in our system. So I want you to go ahead and continue to dump bicarbonate. Versus if it's low and it's saying that, okay, our system is too acidic, after your bicarbonate is filtered, it's going to become reabsorbed by the kidneys. This onset of effect is within 6 to 12 hours.